Bismillahirrahmanirrahim. In this video we will study testing of hypothesis for population mean mu when sigma is known or n greater than 30. Before this we have done testing of hypothesis for population mean mu when sigma is unknown, but in this sigma is known. In previous we have used the word and less than equal to 30, but in this or n greater than 30. So in previous topic, when sigma is unknown and n less than equal to 30 means both conditions should be satisfied, but in this if only one is satisfied, either the sigma is known or n greater than 30, then we apply this method. And what is the difference between this and previous method? In previous method we have used t-test, in this we will use z-test. All these steps are same, method is same, but we will use different formula. For a small sample and sigma is unknown, we use t-test. For large sample or sigma is known, we use z-test. This is called z-test or normal distribution. So steps are same as the previous. There are 6 steps. Method is same, concept is same, theory is same, objective is same, but the formula of the test statistics is different. We will use z-test in this. So first step, null hypothesis, same as previous, mu equal to mu naught, alternate may be not equal to. If this is equal to, this will be not equal to. Not equal to means less than and more than. This is also called two-tailed test. I have explained in previous topic. If null is less than equal to, alternate will be more than. If null is more than equal to, null will be less than, because alternate is the parallel setup of the null hypothesis. Third step, same level of significance, alpha. Fourth step, test statistics, but we use z-test. Formula of the z-test is approximately same as the previous t-test, but instead of s we are using here sigma, because in this sigma is known. In t-test sigma is unknown, we use the sample standard deviation. In z-test this sigma is the population standard deviation. X bar same as previous, sample mean, this is the population mean, this value sample size you will obtain from this, z calculated value or observed result. Fifth step, critical region same as previous, but instead of t we will use here notation z. This z represent the calculated value, this z or z represent the table value or expected result we will obtain from the normal distribution table with the help of alpha. Alpha is the probability of error. In this we will divide by 2. If alternate is not equal to, then we divide it by 2. Left hand side negative, right hand side will be positive, and diagram is same as previous. So this notation is very important, notation of the alternate hypothesis. If this is wrong, this will be wrong. If this is wrong, critical region will be wrong, table value will be wrong, conclusion will be wrong, complete question will be wrong. Second option of the critical region, for less than and more than, less than will be minus z alpha, there is no divided by 2, same as the t-test. This is the diagram for less than and more than, right hand side the critical region, this is the rejected region. Conclusion same as previous, if the calculated value lies in the critical region or rejected region, we reject the null hypothesis, otherwise accept the null hypothesis. So there are 6 steps same as previous topic. Now we will solve question. It has been found from experience that the mean breaking strength of a particular brand of thread is 9.63 Newton with a standard deviation of 1.40 Newton. Recently, a sample of 36 pieces of thread showed a mean breaking strength of 8.93 Newton. Can we conclude at 5% level of significance that the thread has become inferior? You know that surety indicate the null hypothesis and question indicate the alternate hypothesis. I have sent the detail in second last video. So it has been found from experience indicates surety, population value, parameter value. Mean means mu. Why? Because on the basis of large data, if you calculate the mean represented by mu, indicate population mean. Breaking strength of a particular brand of thread is 9.63. This is the population mean, mu. With the standard deviation 1.40 Newton, this is the sigma standard deviation. Why? Because this is the population standard deviation, because it has been found from experience indicate large data, previous data obtained on the basis of research, etc. So this is the sigma and this is the mu. So we write the value of mu in null hypothesis. This indicates surety. Surety indicate null hypothesis. Mu is equal to mu naught is the 9.63. This is the value of mu. And you know that the value of the null and alternate both are same, but notation are different. So this first sentence up to this point represent the null hypothesis and sigma. So with the help of this sigma you can decide. We will use the z test for the mean because sigma is known. Recently, a sample of 36 pieces of thread, n is the sample size is the 36, showed a mean breaking strength. Mean of this sample represented by x bar 8.93. Full stop. Can we conclude 8? Can indicate question. At 5% level of significance alpha 5%, that the thread has become inferior. The question indicate alternate hypothesis. Now thread become inferior. Inferior means less than. Inferior represented by less than. So in this null hypothesis, alternate both are given. Null is given equal to is. Inferior indicate less than 9.63. Substitute all these values in this formula. X bar sample mean mu 9.63, sigma 1.4 and 36. Simplify, you will obtain -3. Next step, critical region. Find the table value. With the help of normal probability distribution table, you have used this table under the heading of the normal probability in class. Okay. So find the table value. Alpha is 0.05. Why? Because it is the less than without divided by 2. 0.05. This is the normal distribution table. This is the area of the probability. First row and first column represent the value of z. Find in this area where is 0.05. This 0.0505 the above than this value, and this is the less than this value, but both are approximately equal or same. So you can take this value minus 1.64 or minus 1.65, or you can take average of minus 1.64 and minus 1.65. So average is minus 1.645. Middle of this minus 1.64 and between this will be equal to 5, or you can take average. So -3 lies left hand side, because -3 is less than the minus 1.645, lies in the rejected region. So calculated value lies in the rejected region. We reject the null hypothesis and conclude that the thread has become inferior at 5% level of significance. Because you are rejecting the null hypothesis means alternate is correct. Alternate correct means the thread has become inferior. Okay. Now next topic, confidence interval for same condition for population mean when sigma is known or n greater than 30. The statement is same if x bar, this is the x bar not x, mean of a random sample of size n from a normal population, with known variance sigma square, with known variance sigma square. In previous we have used the word unknown variance sigma square. Here known variance sigma square, a 1 minus alpha 100% confidence interval for mu is given by. So this formula is also same, approximately same as the t test. Instead of s here we are using sigma, instead of t we are using here z. The concept is same, objective is same. We find the lower and upper value of the population mean. Objective is same, acceptable value of the population mean on the basis of sample data and population standard deviation, previous value, given value, standard value. So this area represented by 1 minus alpha confidence interval. 1 minus alpha, this is the 100% total, 1 minus alpha into 100%. So x bar sample mean, sigma population standard deviation, and sample size. This is the table value we will find from table. If alpha is 5%, this will be 0.025 divided by 2 both sides. So we will now solve question. This is the same as previous question, same question of the previous topic, testing of hypothesis. It has been found from experience the mean breaking strength of a particular variant of thread 9.63. This is given in previous question, but this is not required, because in testing of hypothesis we test either this is accept or reject, but in this we will find the lower and upper acceptable value. With the standard deviation 1.40 we will use sigma in formula of the confidence interval. Sample size 36, showed a mean breaking strength, x bar 8.93, 95% confidence interval, indicate this is the question of the confidence interval only. 95% is equal to 1 minus alpha, so alpha will be equal to 5%. So alpha 1 2 is equal to, alpha is 5%, the alpha 0.2 will be equal to 2.5%, means 0.025. So confidence interval for the mean breaking strength of thread. So we will substitute all the values x bar, sigma, n and table value from table. You will obtain lower and upper value of the population mean. So substitute here sample mean 8.93, this is the sigma, this is the n, and this is the table value we will obtain from table. And same as right hand side, all the values are same. Simplify, first this term bracket, multiply by this value, then subtract from mean left hand side and add in mean in right hand side. You will obtain lower and upper value of the population mean. So we are 95% confident. The question is find the 95% confidence interval. So the conclusion will be we are 95% confident that the population mean of what? Of breaking strength of thread will be lie between 8.47 9.39. From this you can also observe the population mean is 9.63, does not lie in this interval, outside the range, and you have rejected the same data in previous topic in testing of hypothesis. Reject the null hypothesis. Reject the hypothesis mean become inferior, outside the range. If the any given value outside the range indicate reject the null hypothesis. If value lies within the range means accept the null hypothesis. But here we are using same data, so you can observe or compare the previous question of the testing of hypothesis. We have reject the null hypothesis. So the range of the population data will be lie between this and this. And how we find this table value? Alpha is the 5%, alpha upon 2 will be 0.025. Find in the area of the probability 0.0250, the corresponding value is minus 1.96. Okay, 1.96. We write left hand side negative value, right hand side positive value. Either the value is positive or negative. Now homework, For testing of hypothesis, for mu sigma is known or n greater than 30. Chapter number 10 of the testing of hypothesis, page number 312, solve example number 4, and page number 315, question number 3. Homework of the confidence interval, second topic of same condition, chapter number 9, page 262, question number 3 and 4. Okay, Allah Hafiz. Next time we will start